doing well. We feel like I said, therefore, number Hello everyone, hope you all are doing well. Today in this video we are going to discuss a very important topic mostly concerned with the gaseous state for the gaseous molecules. Now, what is the topic that we are going to learn today? So it is all about the collision. Okay, so collision between what? We have studied that in kinetic molecular model according to the kinetic theory of gases. When the gaseous molecules are there within a container, then they are constantly colliding with the wall of the container and also among themselves. Here we are going to discuss whenever the molecules are colliding among themselves, then what are the different attributes of that? Let us understand. Suppose this molecule is colliding with another molecule. Okay, so what is the requirement so that they both collide? So the basic thing is there should be the distance between these two molecules of 2r. Okay, why 2r? Because individual the radius is r for the gaseous molecules, they are identical. So we always assume that the gas molecules are identical. So what is the center to center difference between them is 2r, and this is called sigma. Okay, what is sigma? Sigma is called as collision diameter. Collision diameter. Think about it. So what you can see, look at the board now. The full board is there in front of you. That whenever these two molecules are colliding with each other, then the minimum requirement is that they are having a distance of 2r among them. It is always center to center distance. Center to center distance. Okay. Don't consider that they are touching each other, so no distance. It is not the case here. So you have to see center to center distance. So this is called sigma, and that is called collision diameter. Okay, this is sigma. Now think about it, that suppose if there is a molecule, suppose if the molecule is here, clear, the molecule is colliding here. Okay, and also assume one molecule here. So this is the circle for now, which is having the value, I mean this value is basically 2r here, r here and r here. Okay, so what is the radius? What is the radius of this circle? What is the radius? So the radius will be equals to 2r, and that is equals to sigma. Clear? Now suppose if we consider that in unit time the molecule is traveling a distance which is with the velocity, average velocity is u bar. Clear? So the average velocity, if it is considered to be u bar, so this is actually sigma. Hope you understand. This is actually sigma. Clear? So can you now understand that volume, what is the volume that this molecule is creating in this diagram? Unit time. This has been created in unit time. So in unit time, so I can say volume swept by a single molecule. Think about it. पहले सोचो आप लोग. The video should be completely interactive. Volume swept by a single molecule, ये क्या होना चाहिए? तो बेसिकली देखो ये एक सिलिंड्रिकल फॉर्म आया है, ठीक है? तो अगर हम इसका एरिया देखें वो कितना है पाई इंटू सिग्मा स्क्वायर, बिकॉज पाई आर स्क्वायर होता है तो रेडियस ही 2r है, so it should be pi sigma square multiplied by, you see this is the h actually, this is the height, so that is actually the distance traveled by the molecule in unit time, so that will be multiplied by u bar. So what is the volume swept by a single molecule in what time? In unit time. So we can write volume swept by a single molecule in unit time. You can put it in a bracket, that's better. So it should be pi sigma square into u bar. What is u bar? Is the average velocity. So u bar is the average velocity. Clear? Now my point is that total how many molecules are there? I mean, why we are considering the volume at first? Because we have to think that in whatever volume we are talking about, what are the number of molecules present there? Because the number of molecules what are present there will actually create the collision among themselves, and thus we will get the collision frequency or even the collision number. What is collision number? Number of collisions by a single molecule. What is collision frequency? Number of collisions taking place in a particular system in per unit time, per unit volume. That is called collision frequency. See the difference between these two. Collision number is the number of collisions taking place by a single molecule. And what is the collision frequency? It is, if I consider a system, then within the system, per unit time, per unit volume, number of collisions is called as the collision frequency. Okay. So now my point is, what is the volume swept by a single molecule is equal to this one. So we can assume number of molecules. Okay, we can assume in this way, number of molecules in unit volume. In unit volume, obviously at a particular condition. So number of molecules in unit volume, let us consider this as how much? Suppose n star. So we can assume number of molecules that is present in unit volume is equals to n star. So now think, what is n star? What is this n star? Number of molecules in unit volume. Clear? So if I consider this volume to be V, then I can say therefore number of molecules present in the volume V equal to कितना? This volume में कितना होना चाहिए? Should be pi sigma square into n star. Think about it. Clear? So total volume is V into n star actually. So number of molecules present in the volume V is equals to pi sigma square u bar into n star. Making sense? So think about it. So I can say this is equals to n. We can say like that. Okay. So n is equals to. So what is n? Number of molecules present in the volume V is equals to this much. So now if I consider a single molecule there, so a single molecule will collide with how many molecules? Obviously with this number of molecules. So I hope you have already taken the diagram within your mind so that I can wipe it out. And I can say here that therefore the number of collisions, understand, therefore the number of collisions made by a single molecule, and obviously all those things are in unit time. Clear? In unit time. We can designate this as Z1, and that will be equals to pi sigma square into u bar, that is the volume, and into n star. N star is the number of molecules in unit volume. So this is equals to the collision number. Please note it down. This is what we call as collision number. But there is a big but here. What this big but is, Are we taking the velocity correctly? What is this? Average velocity of a single molecule. But you see, at this time, when we are considering that this is the this should be the value of collision number, that is the number of collisions taking place by a single molecule, or maybe we can even extend that from here we will get the collision frequency at that particular time. We should assume that what we are taking here, we are taking like this, my dear students, that suppose there are 4 molecules here. Clear? And there is a molecule, so everybody is stationary. This is stationary, this is stationary, this is stationary, this is stationary. So this is going and hitting it, this is going and hitting it, this is going and hitting it, this is going and hitting it. Like all those things are stationary and someone is going to hit it. Is that true? No, everyone is moving. Whenever everyone is moving, every molecule is moving, then actually the average velocity should be the velocity joining along the velocity along the lines joining the 2 centers of the 2 colliding molecules. What should be the case? So average velocity, understand? Are you getting my point? This time this means what? That everyone is stationary, only the one molecule, which is the concerned molecule, is going and hitting everyone. But that is not the case. Everyone is moving here. So average velocity, think about it. Average velocity should be, or I should rather say first that average velocity should not be the velocity of a single molecule. Okay, so what should it be? It should be the average velocity along the lines joining the centers of 2 colliding molecules. Are you getting my point? Because that is only the correct assumption of the average velocity, because everyone is moving. So suppose if this one is moving, approaching toward this with a velocity of u bar, and there is a molecule which is also approaching here with the velocity of u bar, so we should actually take they are approaching here, the velocity along this, and obviously this is equals to √2 into u bar. Getting my point? Okay, I think this one is not filming properly. I think you can easily see this, that there is a ball, there is a ball, they are approaching to collide. And why we are taking like this? Because we see that this is also always the maximum possibilities. Because in these cases we always have to go with the possibilities. So these molecules which are going along the perpendiculars, that is the most often found case here, while the molecules are going to collide. There may be a lot of other cases, but what is happening more in number, that should be the consideration. So this one and this one are going and they are hitting over here. So in maximum of the cases, the average velocity we should take when they are approaching perpendicular to each other. Clear? So they are approaching each other perpendicularly. So now obviously what should happen? This formula should not be the working formula. So what should we do? So therefore this Z1 should actually be pi sigma square. This should be √2 into u bar into n star. Are you getting my point? So now the formula is modified. And that is equals to pi sigma square into √2 into u bar into n star. What is n star here? Don't forget that it is the number of molecules in unit volume. Clear? Now this is the collision number. So I can say this is your collision number. Let us collision number. Okay. In most of the cases, this is given by the symbol NC. That is not a very well-known symbol, but generally we can give this as NC. Okay, and collision frequency is given by the value Z. Okay, so as I have given here Z1, you can also consider that to be NC. So it is also equals to, I can write here NC. Now let me explain one beautiful concept here. Suppose if I say A, B, C, D, there are 4 teams who are playing among themselves. There are 4 teams. A is one team, B is one team, C is one team, D is one team. Now they are playing among themselves. So how many matches will be there? So if I consider in this way, that A is playing with 3 others. Similarly, B will play with 3 others, C will play with 3 others, D will play with 3 others. Actually, the total number of matches should be 12. But you think yourself, should it really be 12? No. Like A is playing the match with B, A is playing the match with C, A is playing the match with D. That's okay. Now when I consider B, so B is playing the match with C, B is playing the match with D. So why is that B is playing with the match with B is playing the match with A? And that already has been considered here, because A is playing against B, that means B is playing against A. So while we are considering 12, we are getting a double count. You see, the last possibility will be C is playing with D. Now if you consider here, you will be getting total 6 matches, 1, 2, 3, 4, 5, 6. That is half of this 12. So whenever you are taking a mutual collisions among the number of molecules, actual collisions should be half of the total number of collisions that you are getting by multiplication of the number of collisions, that is considering the number of molecules. Because in that case you are taking a double count. Like suppose this is a molecule named as A is colliding with B, so that means B is also colliding with A. So if you multiply directly with the number of molecules, so you are getting A and B and A, they are the different entities, but they are not actually. So what I want to tell you will be very much clear if you understand the next line of this. That is, my point of view is that therefore the total number of bimolecular collisions, how much it will be? Z11. Z11 means you are bimolecular, means you are taking the identical molecules, similar substance. So that is Z11. So how much it should be? It should be equals to, what is Z1? What is this value? Z1. Z1 is number of collisions taken by a single molecule. So total number of molecules are how much? N star. Total number of molecules are equals to what? Total number of molecules are equals to what? N. So it should be Z1 multiplied by N. Z1 multiplied by N. Let me, or if I consider unit volume, so it will be Z1 multiplied by N star. If I consider in unit volume, so the total number of bimolecular collisions will be in unit volume number of molecules equals to N star, which we have already calculated. And in that volume only, Z1 is equals to this. So Z1 multiplied by N star, and actually it should be multiplied by half. For this reason I gave you that example, that Z1 is basically the number of collisions taking place by 1. So when you multiply that by the total number of molecules here in unit volume, so that will give you the total number of collisions which are getting a double count. That's why you have to divide it by 2. Okay, so I hope this concept is clear to all of you. Number of bimolecular collisions per unit volume per unit time. This is the number of bimolecular collisions equals to this. And what is that? Per unit volume per unit time. Per unit volume. So let us see how much it should be. So Z11 is equals to half into, what is Z1? Z1 is equals to pi sigma square into root 2 U bar into N star multiplied by N star. Are you getting this point? Think about it. So it is equals to how much? It is equals to 1 by root 2 pi sigma square U bar into N star whole square. So we now got a formula here, Z11, that is collision frequency per unit time per unit volume. I have already told you that collision frequency is the number of collisions taking place by the gaseous molecules within the system per unit time per unit volume. So it is 1 by root 2 pi sigma square u bar into n star square. So that is a beautiful formula that we are getting here. Clear? I hope this part is clear to all of you. Those who haven't understood this, if you have any problem, you please see the video again and again, and please in the comment box tell me where you have a doubt. So guys, that is equals to the collision frequency, that is equals to Z11. Now, if I put the, now here is the main idea coming in front of you. Now, suppose if I give it number 1, okay? So we know that average velocity is equals to root over 8 RT by pi m. Lot of things here you must understand. 8 RT by pi m. So if I put this value, so you first put the value by yourself. You do it yourself. You do it yourself. Take some time and do that. I think this one is not visible. So u bar is equals to root over 8 RT by pi m. Now it is visible. Let me check. Yes, it is. So now you find out the value of Z11. Do this yourself. So this is equals to 1 by root 2 into pi into sigma square u bar. We put it root over 8 RT by pi m into n star square. So Z11, how much it should be? So it's cancelled. It's root 4, that is 2. It is sigma. Okay, sometimes it's like smaller, but it is actually sigma. So it is 2 pi root pi. Actually this root pi is coming here. 2 root pi into sigma square into root over RT by m into n star square. So I can write it again. So it is equals to 2 sigma square root over pi RT by m into n star square. Check with your answer. So it is 2 sigma square into n star square pi r root over pi RT by m. I can keep this thing also here. So Z1 is equals to 2 sigma square into n star square root over pi RT by m. So this is your collision frequency. And what is that? It is the bimolecular one. Okay, this is the bimolecular one. So in between like molecules. So the molecules should be same, everybody. The molecules should be same. In between like molecules, identical molecules, similar molecules, we are getting this collision. Clear? Think about it. Think if molecules are unlike, then what? Think if the molecules are unlike, then what? So in that case we use the formula. It is Z12 now. This is important, and this type of numericals are actually very intricate numericals. You should have a very good knowledge of how the derivation of the formula is done. Then only you will be able to apply that. In that case, it should be coming from the first formula. What was the first formula? Let me clear this. So if it is Z12, then basically the main formula should be, what was Z1? Remember what was Z1? Z1 is equals to root over 2 pi sigma square u bar into n star. It is filming? Yeah, you can see this. So Z1 is equals to this. That was multiplied by n star in order to get Z11. But here the scenario is different. That is now not going to be multiplied with the same molecule. So what are the things that will change? Root over 2 into u, it was the formula when we changed the average velocity. Before that, this formula was Z1 is equals to pi sigma square into u bar into n star. So that was our mother formula where we changed this u velocity in a different manner. So that will be the main case in this particular instance. So this time it will be not sigma into sigma, it will be sigma 1 2. That means this sigma was same, because we are considering what? We were considering r as the radius of the molecule, but here there cannot be the r, they are different. So this will become sigma 1 2. So you are considering sigma in different manner. It should be r1 plus r2 actually. They are not identical now. So suppose this one is like this and this one is like this. So it is r1 and this is r2. So together it is r1 plus r2. Clear? Then we generally use the formula root over 8 RT by pi m, but here we will use 8 KT by pi into mu. First you understand the formula. Why is this so? Into multiplication will be N1 into N2. Here two different entities are there. Different molecules are there. They will not be same. So it will be N1 into N2. Now the question is, where from we got this? So what is K? K is Boltzmann constant. So K equals to R by Na. You all know that. And what is mu? Mu is called reduced mass. Many of you have already got this concept. While I think it is going little above. So K is equals to R into Na, and 1 by mu is equals to 1 by m1 plus 1 by m2. This is the concept of reduced mass. In any upcoming videos I can also talk about this if you want me to discuss about it. This is reduced mass, is generally found, like suppose if you are having an electronic system, nucleus is there, you already know that if the mass of the nucleus is m, capital M, and if an electron is moving surrounding, or any object is moving surrounding this, and that is small m, so there is a reduced mass concept, and the reduced mass comes to be like this. Okay, so we are not going to discuss over here, but this formula will be Z12 is equals to pi sigma square 12 root over 8 KT by pi into mu. Okay, so what is not R applicable here, because we are not considering like R by Na. When K will be equal to R? When Na will be equal to 1. But here we are not sure about how many number of molecules. So we will consider it to be the Boltzmann constant instead of the simple R. So we are considering that whole scenario per mole. So therefore it will be 8 KT divided by pi into mu into N1 into N2. That will be Z12. It's a little intricate part. I will suggest you first you complete this part and then take a look at this particular point. Okay. So what was this Z11? Is equals to 2 sigma square into n star square into root over pi RT by m. If they are like molecules, if they are unlike, then this will be the scenario. Hopefully it is understandable to all of you. Now, if I consider collision frequency now, like what was the formula? Finally, what was the formula that we have got? Z11. Think about it. So what was the formula? Formula was Z11, and what was that formula that we have already got? So we have already got this value was equals to pi into sigma square into u bar. Keep it simple. I mean not the root over 8 RT by pi m. So pi sigma square into u bar into n star square. Now the whole multiplied by 1 by root. Okay. If we now consider, I want to put the value of u bar, so it is equals to pi sigma square root over 8 RT by pi m into n star square into 1 by root 2. So what we are getting finally? So we are finally getting 2 into sigma square into n star square root over pi RT by m. Okay, this is the formula we are getting. Now understand, simple concept, very very simple concept, that we know PV is equals to nRT. What is PV? Pressure multiplied by volume of the gas is equals to nRT. So far we are constantly talking about n star. What is n star? N star is number of molecules per unit volume. So from here, can I say N by V is equals to P by RT? Think about it. What is N by V? What is N by V? Don't make a mistake. This is not number of molecules per unit volume. This is number of moles per unit volume. So what is N by V? Number of moles per unit volume. But what we need? Tell me. What we need? We need the number of molecules. So what will be the number of molecules? So number of molecules, if I say number of molecules per unit volume, it should be this multiplied by Na. What is Na? Na is Avogadro number. So number of molecules per unit volume will be equals to this one. So if I give it number 2, so can you see from 2 what we are getting? Z11 is equals to 2 sigma square n star square. Okay, n star square, we can directly put this value n star. In place of n star we can put this P by RT into Na square into root over pi RT by P. Is it clear to all of you? So Z11 is equals to 2 sigma square P by RT into Na square into pi RT root over pi RT by M. So if you consider this, just understand what are the constant terms. Circle it. So this is the constant term. 2 sigma square is the constant term. Okay. What are actually the different terms? Like P is a variable term. T is a variable term. All the other are constant. So I can say Z11 is proportional to P square into T. You see this is T to the power minus 2 into T to the power half. From here it is T to the power half, and from there it is T to the power minus 2. So it is equal proportional to P square into 1 by T to the power 3 by 2. That is very important. So Z11, so how it is depending on pressure and temperature. So Z11 is proportional to P square into 1 by T to the power 3 by 2. Clear? So Z11 is proportional to P square into 1 by T to the power 3 by 2. So this is how we are thinking that the dependency. So if T is kept constant, so from here we are getting two attributes, then Z11 is proportional to P square, and if P is kept constant, so that is proportional to T to the power minus 3 by 2. Okay, so that's all about the collision frequency. How it is, that means if you change pressure, keeping temperature intact, how it will change. If you change temperature, keeping pressure constant, how it will be giving an impact. And if you change both, then how it will be giving you an impact. Now, here comes another concept, which is the concept of mean free path. So mean free path is what? Suppose the molecules are traveling, molecules are colliding with this. Suppose these are the two molecules which are having a collisions among themselves. So they are going apart from each other. Now here it is also colliding with some molecules. It is going like this. Okay, again from here it is colliding with some molecule, then it is going like this. So in this path, how much path it traveled per unit time, and how many collisions it is experiencing. That means we want to calculate that on an average per unit collision it is going how far. Okay, in per unit time, that is called the mean free path. So let me make you understand this one. So suppose it is going from here to here, here to here, here to here, here to here. So this is L1, L2, L3, and so on. So what will be the mean free path? That is given by lambda. So lambda will be equals to L1 plus L2 plus L3 plus L4 plus dot Ln divided by. So n number of collisions it is taking place, or it has taken already. So lambda is the mean free path. That means the average distance it is traveling per unit collision, per obviously unit time. Unit time should always be there. So how should we think about it? If I want to derive the formula of this, then what is actually the lambda? So in between two successive collisions, the average distance traveled. Okay. So we can say that this lambda is equals to, so what should be the formula? Think about it. It is the average distance traveled per unit time. A molecule is traveling after the collision, successive collisions per unit time, and it is number of molecules. Now see, here we are considering a single molecule. माने यही molecule है, यही यहीं जाएगा, ये यहीं आएगा, ये फिर यहीं जाएगा, फिर यहीं जाएगा, फिर यहीं आएगा. So it is, we are considering the one single molecule. So we should always write in denominator number of collisions taking place by a single molecule per unit time. Number of collisions taking place by a single molecule per unit time. So what is the average distance it can travel? What is the velocity of this? And what is the number of collisions? Already I have told you, that is Z1. Z1 is collision number. So what should be the value of this? It is equals to U bar by root over, already we know this, pi sigma square U bar into n star. Remember the formula? Z1, the modified one. So this should be cancelled. So it is not dependent on the velocity. So it is dependent on what? Root 2 pi sigma square into n star. So that is your lambda. Now something very interesting. Here. In this case also we can see that there is n star. Okay. So what was n star? We have already done this formula. PV equals to nRT. So P equals to n by VRT. That is equals to, so I can say n by V equals to P by RT. Okay, so what was n star actually? It was P by RT into NA, Avogadro number. So if I apply this formula here, so lambda is equals to 1 by root 2 into 1 by pi sigma square. N star is here. So if I put the whole value, so it is RT by P into NA. Clear? So from here, see the dependence. So lambda is proportional to P by P. Very important. So lambda is proportional to temperature and is inversely proportional with P. Here comes a very important point as far as physical chemistry is concerned. Okay. Now what is that importance? Let me tell you. So as you can see, if I keep temperature constant, so lambda is proportional to 1 by P. Please do pay attention here. This is something incredible. So now when lambda is proportional to 1 by P, that means if you are decreasing the pressure, suppose this is a system where you have decreased the pressure. Okay, if you have decreased the pressure, then how will lambda change? And if you increase the pressure, then how will lambda change? So what is the physical, what is the physical significance of this? Let me tell you about that. Write down, if you are writing it properly, then please write down that if this P we consider to be 1 atm. Please understand, at the beginning of the video, what I have told, that generally whenever we are considering the kinetic molecular model or kinetic theory of the gases, I have told you that the molecules may have two experiences as far as the collisions are concerned. Number one, it can collide with the wall of the container, or it can collide within themselves. Two possibilities. This lambda will actually signify that the molecule will go to collide with whom. Here is the important fact. So suppose if you consider that the pressure is 1 atmosphere, so lambda is very small because P is high. 1 atm is quite high for this case. So lambda is very small in comparison. Write down, lambda is very small in comparison with the macroscopic dimension. Lambda is very small in comparison with the macroscopic dimension of wall. Like, what is the dimension of the wall? It can be 1 centimeter, it can be 10 centimeters. So lambda is very, very small among that. Are you getting my point? So that means in this particular case, the molecule, the dimension is so high that this lambda and the lambda is so small in comparison to the dimension that the molecules will now prefer to collide among themselves without traveling that dimension which is very far than their distance, than their mean free path. That means lambda is small, that means they are traveling very little distance in comparison to the dimension of the container. So they are not interested to hit the container, rather they are trying to hit themselves. So they are having the collision among themselves. That means when the pressure is high, I have taken the consideration of 1 atm, you can take 2 atm, you can take 3 atm, you can take any value which is higher than 1 atm. And when you make that, then the molecules are now actually compelled to collide among themselves. But if you now consider that if you make a pure vacuum, that means the pressure will be around 10 to the power minus 3 atm, like that, 10 to the power minus 3 or even smaller, 10 to the power minus 4, 10 to the minus 5. So here lambda is very large. Now lambda is very high. So they can lambda is very high. I mean, if one molecule is here, okay, it will not take much time to hit this point. If it is very high, it will go and hit this point. If it is very high, it is going at this point. So that means they are not now interested to collide this one, because their free path is now very high. So they can move freely, as if your jurisdiction of roaming around is very high. Then you would not like to roam around your house. You would like to roam around the whole world, basically. So the same thing is happening here. When the molecule is experiencing the higher value of lambda, then they are from one point, they are going to the another point. That is, now they are you getting my point? So P is very less, and they are getting the lambda very high. So now they are not interested to collide among the molecules. They are colliding with the surface of the walls, and that time these gases are known as Knudsen gas. They are known as Knudsen gas. That is the pronunciation. You can sometimes people take K silent, but it's actually Knudsen gas. So what is this Knudsen gas? It is basically when the gaseous molecules are having very low pressure and they are having large lambda, then from one place to another place they are moving, they are going far away from each other, and that's why they want to collide with the surface of the container and not among themselves. Clear? That is the attribute of this gas. Making sense? So that's all, everybody. For the collision frequency, I have to take a lot of things. I want to discuss something more, but I am keeping this topic up to this so that at least at first you digest this part, apply these concepts to some problems, some numericals, and you can ask me for the numericals also, I will send you. But the main thing is, once you get this concept, it will be easier for you to climb to the higher tree. Okay, so guys, just be well, take care of yourself. That's all from my side. Thank you very much.